Hey, look at all these people. Oh shoot. Well, you're in. Can I put my blanket up on that?
Yeah, I'll go out there.
What do you say?
I just started.
In like a minute. Starts at 12:30.
Let me get this off right now.
I have a staff meeting tomorrow at 9. That's a bummer.
Hey, Mom.
She's in the restroom.
She's in the
She's in the closet. She's in the closet. She needs to come out of the closet.
Yeah.
Okay. Come on out, Ro.
Hi, baby. Did you go pee-pee?
Okay.
Okay.
All right, Ro, I'm going to start my
You dipped your
happy
toast in
little
butter, or
meeting.
did Dad do that for you?
Yeah. Hey, first of all, can you guys hear me?
Yeah.
You can? Okay. Do I sound normal or do I sound like a robot?
You sound fine.
Sound fine. Thank you, Alexa. Okay, here's what's going to happen. I didn't put this in the last email because, frankly, I didn't think of it until like 5 minutes ago. But I need to be giving you guys extra credit for this. So essentially, from now on, every meeting you attend for the full 45 minutes and do AP exam problems will get you 2 points extra credit. So you'll have a chance to get, maybe what, 20 or 16 or 20 points extra credit, which is a significant amount in my grading system. So, hey, welcome, and let's get started. We're gonna do this, the blue book. There's my cute daughter. We're going to. There are 2 sources for free response questions, and the only types of questions we're going to do together are free response questions. There's the ones you find on the internet with apcentral.com. Those are the free response questions that were given on actual AP exams. And then there's the free response questions that we teachers were given that are like extra for you guys to practice. Also, there's the free response questions that are on that AP classroom or whatever. And frankly, I've never looked at it, so I don't know which of the free response questions they're using, whether it's the ones I get, or is it the ones that are actually on the old AP exams, or is it both? I have no idea. But you've got access to everything just between this book and what you would find on apcentral.com for the old free response questions. So what I would recommend is our times together. Well, of course, you should be doing lots and lots of problems regardless. But if you wanted to decide what types of problems to do, I would say do the old AP exam problems on your own and do these guys with me during these sessions. But try to do, ideally, if you can do like 50 problems between now and a month from now, which is about when your AP exam is, if you can do 50 free response questions between now and then, you'll be pretty much as ready as you can be. So you should be having that as a personal goal, 50 questions. My role during this time together is to give you insight into what they expect, make sure that you maximize your points. I don't want a situation where you know how to do something and yet you don't get the maximum amount of points because you don't write enough stuff down or something. So that's what I'm going to do, is try to teach you how to do this. Okay, so what I'd like you to do is please open to the 2014 free response questions. It's in this blue book and it's on page 59. So if you go to page 59 in this blue book, you'll see problem 1, which is the problem with momentum and energy, but it initially is momentum. And I would like you to, you've got supposedly 13 minutes. I'm going to give you like 20. So I'm going to declare you done at 12:53. Go ahead and do problem number 1 from the 2014 free response. It's on page 59 in this book. So good luck. Do problem number 1 now. And if anyone has any questions or issues, let me know.
I got temporarily kicked out of the meeting, but so we're doing problem number 1 from where? From 2000 what?
2014.
Oh, okay.
Problem number 1 from 2014. It's on page 59 of this blue book that I gave you guys.
Okay, thank you.
You're welcome. If you don't have the blue book, then you'll just have to do your own thing. You'll have to do problems off the internet.
Mr. Shana,
Yes.
upload the blank document on Google Classroom.
I'm sorry, say that again?
Where do we upload the blank document on Google Classroom?
You mean for checking in?
Yeah.
Have I created that yet?
I
I don't think I have. Have I? Where it says check in Thursday 4/16?
I don't think you have.
Oh, bummer. Yeah, so I'll do it after we're done. So yeah, so don't worry about
Oh.
checking in now. But actually what I'm doing right now is I'm actually taking roll. So I'm determining who's here by literally, looking at everyone who's here and writing them down, you know, the old fashioned way.
Mr. Shana, I just joined. So all right, I don't know what happened or what went on.
Yeah.
So what did I miss?
We're going, that blue booklet that I gave you guys?
Oh yeah.
That has all the old tests. Go to page 59 in the blue book and do problem number 1 from 2014.
Oh, okay. Thank you.
That's what we're doing right now.
Okay, thank you.
You're welcome.
What if we don't have the booklet?
What if what? If you don't have the blue book?
The
Wait. Go ahead, Adam. I'm not hearing you, Adam. Is it me? Stupid Zoom. Because it says you're talking, but I can't hear you. Here.
Sorry, it was like cutting out. But yeah, I think I was absent the day you got the booklet. It was first weekend Saturday, and I don't think I could have made it.
Well, the blue book, I actually had you checking it out like weeks before the end of school, and I reminded you every day of the week, our last week together. And if you don't have the blue book, then all I can tell you is you're going to have to just on your own do problems from the internet or problems from AP Classroom. So yeah, you won't be able to do the problems that are in the booklet if you don't have the booklet.
Okay, yeah, maybe I do have it. I'll look for it. Thank you.
Okay. Oh, Jordan's here.
giving your students extra credit.
Yeah, you know.
Very smart.
Huh. Wow. You have 5 more minutes.
Bless you.
Two minutes left. All righty. Hey, time's up. So looking at part A, tell me, how do you know that the measurements were not started at the instant the carts were released? How do you know that the answer is no?
Because it said that it was initially at rest.
Bummer. Could you repeat that? My audio for you was bad. What was that?
Was it because it said that it was initially at rest?
Yeah, good. And according to the graph, are they initially at rest?
No.
Yeah, so good. Good for you. So you guys okay with that? So the answer is no, because the problem says they're initially at rest, but the graph has them with an initial amount of momentum. Okay, look at part B. They're asking for force. They give you a graph of momentum and time. What concept should you be thinking of right now?
Like the impulse and momentum. Oh,
Impulse.
there's like force
Absolutely.
times time.
No.
Yeah, impulse momentum. That's it. So you got force times the change in time equals the change in momentum. That's what you should be thinking. And I just wrote that on my page, but I'm lagging about 20 seconds. Great. So it's that simple. The time is 10 seconds and the change in momentum, all you have to do is get the initial momentum and subtract it from the final momentum of the system, of the entire system, you know? And so my final momentum, what is that, like negative 0.6, it looks like, for the 1 kilogram and positive 1.25. So I got 1.25 minus 0.6, which is 0.65. So my final momentum appears to be 0.65 kilogram meters per second. And my initial momentum looks like 0.25 and what is that, like 0.2, negative point. So that's positive 0.05. I mean, I don't know what the book is giving you, but I'm getting that, you know. So I got a force of 0.06 newtons. So did anyone get an answer like this? Is 0.06 newtons about what you guys got? And is there any question or issue on how I got the initial and final momentum?
Yeah, Mr. Shanick, could you repeat how you got the momentum again? Do you just
Yes.
look at the graph and then
Yeah, you look at the y coordinates of the graph. I mean,
Mhm.
looking at the values at 10 seconds, it looks like the momentum of the 5 kilogram is like 1.25, and the
Mhm.
momentum of the 1 kilogram is negative 0.6. So I just did positive 1.25 plus negative 0.6 and got positive 0.65.
Oh, so you're supposed to subtract the momentum from um the between the 5 kilogram mass and cart and then the 1 kilogram mass and cart?
Well, they want the force on the entire system, so I had to find the momentum of the entire system.
Oh, okay, okay.
And
I
so,
see.
yeah, the momentum of the entire system is the sum of the momentum of the point of the 5 kilogram and 1 kilogram masses.
Okay, thank you.
You're welcome. Yeah, it's kind of weird. They give us this graph, and usually we're getting the slope and assigning some sort of meaning to the slope, but not in this case. Yeah.
Wait, how did you get 0.65 and 0.05 again?
I looked at the y coordinates at 10 seconds. The momentum of the 5 kilogram mass is 1.25 approximately. And at 10 seconds, the momentum of the 1 kilogram mass is negative 0.6. And so I just did 1.25 plus negative 0.6 to get the total momentum of the system at the end.
Oh, so why did you write 0.65 minus 0.05, not
Oh,
1.25?
because I have to get the change in momentum from the time of 10 seconds to the time of 0 seconds. So the 0.65 is the momentum of the
Oh,
system at 10 seconds. Yeah, the 0.05 is the momentum at 0 seconds, which I got 0.25 minus I mean, well, 0.25 plus what appeared to me to be 0.2. I don't know. It looks like, I mean, negative 0.2. So I did positive 0.25 plus negative 0.2 to get just 0.05, positive 0.05. And I had to subtract it because I'm getting the difference of the momentums.
and you don't have to consider the force of gravity on it because that's in the um x no y coordinate plane, right?
Well, actually, believe it or not, the only external force happening on this system, there's like two forces on the system. There's the magnetic force that's making the two carts repel each other. And then there's gravity, because this track, if I can draw the track, the track looks like this. Wait, let me see. Wouldn't they say the initially they are blah, blah, the track is not with the right side slightly lower than left side. Yeah. So we're looking at something like this, where here's your magnet, let's say, but the track is lower on the right than on the left. So the only two forces acting on these carts are the magnetic forces and gravity. And gravity is the external force. The only external force happening on this system is gravity. So
So are you only finding the x direction of gravity like
that's
parallel to
yes,
okay.
yes, we are.
So when it says external force, it doesn't necessarily mean mg. It just means the force
Correct.
that's actually causing the change in momentum.
Yeah,
Okay.
yeah. And, you know, because the net external force is only the x component. The y component of gravity, the external force, is balanced by another external force, normal force. So the external forces in the y direction cancel, and the only external force, the only net external force on the system is the x component of gravity, as you said. And in fact, Jessica, what you're talking about brings us to part C. Suppose the experiment is repeated with different carts, where one cart's 2 kilograms and the other's 4 kilograms. Would the answer to part B, would that net external force be any different? Oh, my
I'm sorry, Mr. Sheena, you cut out a bit. Could you repeat it?
Thank you, Ryan.
Yeah, you cut out like that whole time.
Okay. Okay, I was going to switch to part C, where part C says, what if the carts were 2 kilograms and 4 kilograms instead of 1 kilogram and 5 kilograms? Would the external force be any different? And were you able to hear, was I coming through when I just now? Zoom sucks.
Yes, but I think that they would it, I think it would be different.
Well, here's the thing. The only net external force happening is gravity, right?
Oh, and gravity isn't changing.
Yeah, well, what hasn't changed between the 1 and the 5 carts and then the 2 and the 4 cart? What hasn't changed?
Oh, the total mass?
Yeah, the total mass. Good. And so since the total mass hasn't changed and your only external force is gravity, then the gravity force isn't going to change either. So, hey, that's the way to do this problem. That's the way I would do it, you know, pretty quick. Any questions or issues? Now, you may lose points because maybe they would want you to use the slope, but I'd say, I don't know, I wouldn't. I mean, I would be willing to lose a point in order to get this problem done this quickly, you know, and not use the slope. Just go delta P, you know, just go initial and final, and I don't care what happens in between, you know. That's what I would do. Okay, well then, hey, let's oh, any questions or issues on this?
Whenever it says justify your answer, do you necessarily have to use numbers, or could you like explain it in detail and words?
In fact, they prefer words. When they say justify, well, you know, when they say explain, definitely it means words and nothing but words. But when they say justify, you can also have equations involved. So like, how did you justify it on part A? Or which part are you talking about, A or C?
No, I was just saying, like, in general, like if
Oh.
we had to use numbers or if we just use words. But apparently we're supposed to just use both.
Yeah, they can. Yeah,
we
you
could.
can use both for justify.
Okay.
Cool.
Thank you.
Anything else? Okay, then, hey, we've got 11 minutes together approximately, though I could keep you longer if I wanted to 1:30-ish. Let's see what the other problems look like on 2014. Just a second here. So I've got problem 2, which hangs a 125 kilogram object on a spring and sets it into oscillation. Oh my gosh, I have forgotten what. Do you remember what are they saying is not on? Is waves on it? Is simple harmonic motion on the test?
I think you said it was. I'm
Shouldn't,
not sure.
yeah, that shouldn't be.
Wait, say that again. It is or is not?
It should not be.
Not? Okay. Then, oh, okay, but, okay, obtains the blah, blah, blah on the grid, sketch the potential energy of, although I think this could be on there. Oh, and then there's the experiment portion. They would expect you to know the spring potential energy. Shoot. Let me see. Maybe because that's like our experimental problem. Let me look at number 4. Yeah. Number 5. Hey, do me a favor. In our last time together, let's actually skip to number 5. I'd like everyone, number 5 is definitely the type of problem you're going to see. It's what they call their short paragraph problem. So I'd like everyone I'll give you about 10 minutes, although they say you're supposed to have 13. I'll give you 13 minutes because we're supposed to be doing this till 1:30, and do number 5. So you've got 13 minutes to do number 5. Good luck. So we're doing number 5.
Mr. Shayna,
Yes.
and so in these explanations, I know like we're not really supposed to have like mathematical like we're not supposed to solve anything mathematically, but can we put like formulas or
Yeah, definitely put formulas.
okay.
Okay. Okay. I'm going to give you 7 more minutes, and then we'll go over this together. Oh. You got 2 more minutes. All righty. Hey, kids, go to page 66 in your little booklet, and you should have a page that looks like this. And I would say go through your answer and just see how many of these points you got. Okay, can I say a few words? And are you guys, by a show of hands, like, can you guys hear me okay? Let me stop share, because I don't get to see you guys. Wait. Okay, good. So Ryan says he can hear me. That's great. Okay, so first of all, whenever things are sliding down ramps or rolling down ramps, you know it's going to be a conservation of energy situation. Because the only force that's doing work on the system is gravity, and gravity is a conservative force. So you're going to get conservation of mechanical energy. So that was the first thing you're going to have to do. Also, are you guys okay when they talk, one of those points is using momentum or forces to explain the motion in each trial. And I want to say something about momentum. In the first case, where the plane is free to move, you can say that the momentum in the x direction has to be conserved because there's no external force in the x direction. There's gravity, but that force is in the y direction. You see? But there's no net external force in the x direction happening on trial 1. And so if your block is moving to the right, then that inclined plane has to move to the left. So momentum is conserved. Whereas in trial 2, momentum is still conserved, but now as the block moves to the right, the plane, which is attached to a table, which is attached to the earth, all of that has to move to the left. So essentially you've got conservation of momentum where the momentum of the block to the right has to equal the momentum of the earth to the left, which means essentially, nothing's going to move to the left because it's so massive. So that's why you just get the block moving to the right with no apparent motion to the left, because what's moving to the left is the earth. Did anyone have any questions or issues concerning their own particular answer? Are you guys good on that? Thank you for the thumbs up, Ryan. Well then, yay, Dominic. Well then, hey kids, then I guess I'm just gonna say goodbye. I need to post after my robotics lesson. I'll post the check-in thing. And everyone here got 2 points extra credit. I had a couple of people who came a little later, Ryan Mallon and Adam Irvin, but you guys are gonna get 2 points extra credit as well, because the parable of the workers, in the field, where even the people who come at the very, very end get the same salary as the people who were there all day. And then I guess I'll say good. So any other questions, any last questions or issues before we end our meeting?
I'm starting to, or I just realized that like when we're doing problems like 5 or where it says like indicate just justify your answer in a clear, coherent paragraph length explanation. It wants us to like almost explain like every motion or every part of the actual like physics. Like it wants us to describe almost everything that's happening in the instance, right?
Yeah, even stuff that seems so obvious that it would go without saying, they want you to say it.
Oh, okay. See, that's what I didn't note out, because I thought it was more common sense, but it was just like, okay, you have to actually include this.
Exactly. And definitely one of the problems you get on your actual AP exam will be of that form of number 5, what they call the paragraph answer.
Okay.
Yeah, just say it all. Okay, kids.
Okay.
Well, then anything else?
Oh, I just had one more question. When it says like you get a point for any mention of energy conversion, what could you have said to get that point?
If you just said that your system starts with gravitational potential energy and it gets converted to kinetic energy, anything like that would have gotten you a point.
Okay.
Yeah.
Thank you.
You're welcome. Okay, then, kids, we're ending the meeting. So goodbye, and I'll talk to you guys. I'll talk to you guys Tuesday.
All right, goodbye.
Bye-bye.
Bye.
Thank you.
Thank you.
Bye.
Bye. I'm ending meeting. End meeting.